All right, today let's solve a free fall problem using the quadratic formula. So here's the problem. A ball is thrown upwards off a 55-foot tower at 80 feet a second. We want to graph its height versus time. And this height equation is not going to be factorable. So what we'll do is we'll solve it using the quadratic formula. So step one, write the height equation. So height is going to be a function of time. And that's going to equal negative 16 t squared. So on Earth, it's always negative 16 plus the velocity 80 times time plus the initial height, which is 55 feet. Okay, so that's the height equation. It'll give us the height at any time after we let go of it. All right, step one, you try to factor it, and you might try factoring, or you might try the quadratic formula, see if it comes out evenly, and you notice that it doesn't. So then what you do is you say, well, I'll use the quadratic formula. So this is A, this term is B plus 80, and the last number is C plus 55. So we're going to put those right into the quadratic formula. T is going to equal negative B, so it'll be negative 80. Divided by 2a, so 2 times negative 16, and then plus or minus the square root of b squared, so that's 80 squared, minus 4 times a, which is negative 16, times c, which is 55. That whole thing is going to be divided by 2 times negative 16, which is 32. You don't have to put a negative in front of this because you're going to add and subtract it. So you don't need a negative in the denominator. So we're going to do this on our calculator. So I'm going to start with the negative 80 divided by negative 32. So negative 80 divided by negative 32. I didn't put the negatives in there because I know it's going to come out positive. And that's going to be 2.5. That 2.5 is also going to be the axis of symmetry. So right away we know the peak is going to occur at 2.5 seconds. So you can draw the axis of symmetry right in there on your graph if you'd like to right at that time. 2.5 seconds will be when the peak occurs. The next is going to be, I'm going to do inside the radical first. So I'm going to go 80 squared minus 4 times negative 16 times 55, all in one step. Don't put any parentheses in there. And that's 9920, so it's going to be the square root of 9920. Then I'm going to divide it by 32. So I take the square root, and then I divide by 32, and I'm going to put that number in memory. That's 3.11. So the x-intercepts, where the height is going to equal 0, is going to be at 2.5 plus or minus 3.11. So it's going to give us two answers, two x-intercepts. One time is going to be 5.61 seconds. So that's going to be over here. This is 5 seconds, 1, 2, 3, 4, 5 seconds. So 5.61 will be right here. And the other is going to be, if I subtract, negative 0.61. That'll be over here, the other end of the x-axis, okay? So that's going to be the base of the parabola right there. We know the peak is going to be at 2.5 seconds. So the next step is going to be, so these are going to be the x-intercepts here, 5.61 comma 0, negative 0.61 comma 0. That's going to be the x-intercepts. When the ball lands, it's going to be 5.61 seconds. So this number right here. Okay? Next is going to come, let's find out the height at the peak. Where's the vertex? So I'm going to take 2.5 and put that back into the original equation. So I'm going to put that in memory in my calculator. I also want to know what time it's going to be at 1.75 feet. I'm sorry, 1.75 seconds. And the symmetric point to that. So I'll find that a little bit later. So let me put 1.75 into my calculator as a constant right now also. So it makes it really easy to calculate the height if I know the times. I put them in there ahead of time. So I just type in negative 16, recall a squared plus 80 recall A, plus 55. And the height at the peak is going to be 155 feet. So 2.5, comma 155 will be the peak. And we can plot that. This is 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 10, 20, 30, 40, 50. So 155 would be right here. 2.5 seconds, it'll be 155 feet above the ground. That's what the height equation tells us. Now I'm going to make it see what it is at 1.75 seconds. So I change that A to a recall B. 2 places. Push equals, and that'll be 146 feet. So 1.75 seconds will be 146 feet. That's right around here. Okay, and then to find the symmetric point on the other side, we take 2.5 minus 1.75. So 2.5 is the axis of symmetry minus 1.75. And that's 0.75. And then we add that to 2.5. And we get the symmetric point to be 3.25 seconds. So that's going to be over here. Okay, that's 3.25. And that just means that 3.25 is going to be equally distant the same time from the axis of symmetry as 1.75. So 1.75, let's see, that's 0.75 seconds away from 2.5. If we go 0.75 on the other side, we end up at 3.25. So that'll be 146 feet also. So these two times have the same exact height because they're equidistant on either side of the axis of symmetry, same distance away. Lastly, we're going to find the y-intercept, and that's just going to be where the number by itself is. So that's 0 times 0. The ball will be at 55 feet. So in this term and this term, I have 0 in for t. The only number left is 55. So here at the x on the y-intercept, on the y-axis, it's going to be 55 feet at 0 seconds. Then we go again across the axis of symmetry, the same distance the other side. If it's 2.5 seconds, the axis of symmetry, it's pretty easy to double that. 2.5 doubled is going to be 5 seconds. So I'm going to go 2.5 seconds on the other side of the axis of symmetry. That'll be 5 seconds. So there's my 7 points, and that's going to make a nice smooth curve. And that'll be my free fall trajectory, or the height as a function of time, anytime after I throw this ball upwards in the air until it lands. Thanks very much. Let me know if you have questions on that. Oh, you know what? One more thing. I'm sorry. Let me write down the other. The symmetric point here is going to be 5 seconds and 55 feet. So that's this point right here. All right. Thanks for watching. Let me know if you have questions.